What's up, guys? Welcome back to the eCoreAcademy e-learning platform today. My name is AJay Raj, back with a geometry video for you all. And today's lesson topic is all about measuring length. It's yet another basic geometry topic and concept that I'm sure many of you are already acquainted with, but I just want to go over it in terms of geometry. So there's different properties and postulates that come with actually measuring length, and that will actually later on will actually serve as a proper point and will actually help you in further cases throughout geometry and throughout measurement in general, because we know that geometry has to do with lots of figures, line segments, and it's very important that we get to understand how we can measure those line segments and how we can correlate these line segments through length relationships. But before we get into today's lesson, please make sure to subscribe down below to our YouTube channel, hit that like button on this specific video, as well as hitting that post notification bell to get notified on any of our channel's latest posts at eCoreAcademy. It is all very greatly appreciated. So like I said, today's topic is all about measuring length, and the very specific theme and purpose of today's lesson is to discover what the properties of measurement are in geometry, and not just in real life, but specific to geometry and in forms of algebraic equations, and how are they executed? How do we execute these properties of measurement to actually correlate length between figures, line segments, etc.? So let's get right into it. Now, it's very important that since we're discovering the measurement of length, we first understand what length itself is. What is the essence of length, and what is its actual definition in geometry? So we're going to discover all about the length. So the length is the measurement of the extent of one end of a line to another end. So basically, it's a measurement of how wide or how long a line is, depending on what kind of dimension you're describing this line within. So I'm going to draw a little example here. Say, for example, you have a line like this, or even a line segment. So if a line like this, right? Or even a line segment, like I said before, a line segment has a finite length, meaning it has a definite length, while a line has an infinite length. So if we focus on this line segment right here, and we X out this line here because we cannot figure out the length of a line, and we look at this line segment here, what the length of this line segment would technically be is the distance from this point to the other point. So I'm going to name this point A right here, and point B. And so basically the distance of this entire line right here would be the distance between point A and point B. It's very simple. It's the distance between the two endpoints of any line, and that goes along with any figure because every figure is defined by some sort of arrangement of line segments. Now, length is measured in terms of variables and or existing units such as centimeters and inches. And what I mean by that is, say, for example, you know how to figure out the length of a line segment as shown here, right here for line AB. But you have to be able to express it in some terms of relativity. So in order to do that, you have to have some sort of unit, some sort of base. So you can use variables to describe relationships between two line segments. Say, for example, you have one line that's this big, and then you have another line that's this big. And as you can see, this line is most likely going to be 1/2 the length of this larger line. So what you can say is, if you name this line A, and if you name this line B, you can say that A is equivalent to 1/2 B, and that's in forms of algebra. It's in forms of equational format. And what you can also do is you can express it in forms of centimeters and inches. If you have a ruler, a meter stick, depending on the metric system or a customary system, you can use that to describe them in sources of centimeters, inches, meters, all the kilometers, yards, depending on how large you're going and how relative it is to the certain situation that you're given. And finally, length, like I said, it's also measured and represented in units. The actual measuring part of it, the physical part where you actually measure a certain length of a line segment, that's going to be done by physical objects such as rulers, meter sticks, and it can also even be expressed in algebraic form just to calculate a measurement. Like I said, algebra is very powerful in expressing the unknown and even expressing the unrepresented. So let's move on. Now we're going to focus on what line relativity is. So line relativity is just basically all about congruence and similarity. And if you look here, congruent being the descriptive word here, congruent, basically expresses that two objects or two lines have the same shape and size but differ in position. So if two line segments, I'm going to put this in terms of line segments since we're focusing on length internally. If we have two line segments, like this line segment here and another one here, I'm going to name this one line segment B and line segment A so that we're organized and we know what I'm talking about. And if we look at these two line segments, and we say that both of these two line segments are congruent, that means both of these line segments, line segment A and line segment B, both have the same exact shape, meaning that they're both a line, both a line segment, and they both have the same exact size. So in this term, in relation to this problem here, they would both have the same exact length. And no matter what type of unit it is, they must have a congruent or same equivalent length. But the thing about congruent shapes is, or congruent lines in general, they cannot have the same position. So they must have different positions. If not, they would be on top of each other, which you cannot be sure to see if there are two different figures shown. And now we're going to go to similar, which is basically very similar to congruent shapes. And similar just means that if two objects are similar, they have the same shape, but they differ in both size and position. So say, for example, we have a line segment here. Like I said, line segment A and line segment B as the same line segments above. And say, for example, these two line segments are not of the same length, but since they are both line segments, which makes them both of the same shape, and since they differ in position, they would both be considered similar and not congruent. So these are similar figures, and these up here are congruent. And it's not too large of a difference, but congruency has a bit more of qualifications. And I just wanted to throw this in here. Equilateral triangles, which are triangles that have three equivalent sides and three equivalent angles, are always similar since their angle measurements are always equivalent to 60 degrees, but they're not always congruent. And a lot of people might be confused about this. You might even be visiting this video just for this reason, but I will definitely go into that in a bit more depth in later videos. But I just wanted to get that out there if you had that question, say, for example, on a certain practice problem, or you just wanted to know out of curiosity. So now we're going to go into the actual meat of this lesson, and we're going to look into what these postulates and properties, postulates just meaning theorems and laws in geometry, and we're going to look at these properties of measuring length. And these include the process and the different situations that you might come across. So the first postulate that we have is the ruler postulate. Now, a ruler postulate is a form of measurement, and I will show you what that looks like. So a ruler basically looks like a line. It's like, if you don't know what a ruler is, you might think of a meter stick. It's something similar to that. It's equivalent to approximately 30 centimeters and 12 inches. So it's marked off like this with different lines on the edges, and that's used to measure. That's physical measurement. And this is not in terms of algebra. This is physical in real life. So the ruler postulate states that the points on a line can be numbered so that positive differences measure distances. Now, I know you might be very confused by what I mean by that, but all it's looking at is what is given on a ruler. So say, for example, we're given a line right here, right? No, I'm not going to give it a name yet because it's nothing specific. And if we use this ruler here and say, for example, we're trying to measure this line segment, and we see that the ruler is listed in inches, so I'm going to mark off what the ruler looks like. So 1, 2, these dashes represent the numbers, 4, 5, 6, 7. And what we're basically doing is, it's saying that if you look at one of the endpoints, and if one of those endpoints are lined up at the 1 inch mark, and you're able to calculate how far it goes until its other endpoint, which is at the 7 inch mark in this case, which is not going to always be the case, but it should always start at the 1 inch mark in the dead space of the ruler. And if it ends at the 7 inch mark, all you're doing is you're discovering the positive difference between the distances. So you're basically subtracting 7 and 1 to get 6 inches as its difference. Or you can put it in centimeters, inches, depending on what kind of ruler you're given. And I want to just throw this out there. Absolute value represents distance. So I'm sure you've heard of absolute value. For example, we're given the variable x. Absolute value of x equals negative. Absolute value of x always equals x. Meaning, if you're taking 7 minus 1, or if you're trying to calculate the distance between 1 inch and 7 inches, what you would have to do is you would have to subtract either one from the other. So if you subtract 7 minus 1, you get 6, and the absolute value of 6 is always 6. So what absolute value does, it makes any value within these two bars positive. It makes every value within those two bars positive. So, but you could also do 1 minus 7, which equals negative 6. Now, if you put negative 6, since 6 is a negative, that actually cannot be, because I want to write this down here. Distance in general must always be positive. Distance equals positive, because you cannot have negative distance, and I will explain that later on as well. But distance will always be positive. Very important that you know that. And yeah, going back to this, if you subtract 1 minus 7 and that equals negative 6, you would always do the absolute value of negative 6 to get that the distance is 6 in whatever units that you're representing it in. All right, let's move on to the second postulate and to the second postulate and scenario, and we will have 2 more after this one right here. Yeah, so we have 2 more postulates and properties to go to. And so the second postulate that we're going to come across is the segment addition postulate. And the segment addition postulate, I know it looks lengthy, but it's describing a certain scenario through algebraic terms. So this is strictly algebraic, but it can be related to real-life situations when you're physically measuring certain line segments or even figures. So if we look at segment addition postulate, it states that if B being any number, it's represented in the form of a variable. If B is between A and C, then AB plus BC equals AC. So I'll draw that out for you. So if you're given a line here, like this, a line segment, excuse my line there. If B, so say for example, we're going to draw B here. If it's between points A and C, like I show you here, AC is the line here, and point B is between that, then what it's saying is that AB plus BC equals AC. And that makes sense if you look at this. If you see the distance between AB, you see that AB plus BC, meaning the combined length of this segment, AB, and BC equals AC, because since B is between both A and C, and you're basically splitting up the length into the line segment into 2 proportional line segments, different line segments. That means that the distance between AB and BC is always going to be the distance between the 2 endpoints, since you're calculating the total distance. So that is always true. And also, this is a corollary, which is basically the total opposite of it, but it's also true. If AB plus BC equals if AB plus BC equals AC, and A, B, and C are collinear, which means they're all on the same exact line, then B must be between A and C, and that is always true as shown in this situation. And I just want you to know that this postulate falls under the law of a midpoint, which splits a line into 2 equal segments. Now, I know you might be thinking, wait, does it necessarily have to be a midpoint? Not necessarily, but in any line segment that you're splitting, you should always find the middle of that line and always plot that point. So what you can do is you can calculate the further line, the further point that you're trying to distinguish, and you can use the midpoint formula, which I will go on in I will show you what it is later on. But this is what the midpoint formula is. If you guys need it now, you can just jot it down, but I will get to it in a later lesson. So the midpoint formula is, I'm not going to explain it yet, but if you guys want to know what it is, I'll just write it down for you. So it's x1 plus x2 over 2, and this is in the form of coordinates, comma y1 plus y2 over 2, which is basically finding the average of coordinates, and I'll explain that entirely. All right, guys, so that'll be the end of today's video. Hope you guys enjoyed. This was all about the measuring length and the different postulates that you're going to come across and properties. So I hope you guys enjoyed. Before you guys leave, please make sure to like and subscribe down below to our YouTube channel at eCoreAcademy, and please hit that post notification bell to get notified on any of our latest posts. And just like I did, I went back a little bit. Please make sure you pause the video at any points that you need, so you can make sure to jot down any notes that you might want to recollect for any further reference. It's very important that you do so, because geometry has plenty of information that you might need to retain. So, before you guys leave, please visit our website at eCoreAcademy.org if you're viewing this through our YouTube channel. On our website at eCoreAcademy, we have full unlocked access to all of our integrated quizzes, our note sheets, and our worksheets that go along with each and every single video, as well as visiting our Gmail at eCoreAcademy@gmail.com. Emailing us at our Gmail at eCoreAcademy@gmail if you want to reach out to us or ask us any questions. And please visit all of our socials at Facebook, Twitter, and Instagram to share all of our videos and help us out. So thank you guys. Hope you guys enjoyed, and I will see you all in the next video. It's been AJ, and peace.